A ball is thrown vertically up from the point A. A person standing at a height h on the roof of a building tries to catch it. He misses the catch. The ball overshoots and simultaneously the person starts a stopwatch. The ball reaches its highest point and he manages to catch it upon its return. By this time, a time interval t has elapsed as recorded by the stopwatch. If g is the acceleration due to gravity at this place, the speed with which the ball was thrown from point A will be. So in the question, the initial velocity with which the ball was thrown has been asked to us. So the question says, let me explain the question to you. This is the figure, this is the diagram. So from here, a ball is thrown with some initial velocity. Let's suppose the initial velocity be u, which we have to find. And from at this point, this is the roof of a building. Let's suppose a man is standing here. A man is standing here and he's trying to catch the ball when the ball reaches this point, but he misses the catch and the ball goes like this and comes back. And when it comes back at this point, the man manages to catch the ball. The man catches the ball at this point. So the time, and one more information also given here, the time for this journey from this point to this point is t. Time for this journey is t. So what is asked to us is this initial velocity, and this is the height given to us, height of the building. So for finding the initial velocity, first of all we will consider this motion. We will consider the motion from here, this particular, from here to here we will consider the motion. If the ball moves from here to here, we will consider this motion, only this, when it reaches its maximum height. So for this motion, we have t. We have this time. For this motion, time is equal to capital T by 2. Since for this motion the time is t, so for this motion the time must be t by 2, because it is the half of the time for this whole, and for this t, for this journey the time is half of that journey. So I think you have understood. So t is t by 2. Acceleration is g only. Acceleration is g. With us acceleration is g only. Height is not given in this question. Height is not given, so we will not take height. What else is given? Final velocity. When it will reach the final position, this final velocity at this point, let me write it with this red pen. Final velocity would be 0 at this point, isn't it? Final velocity would be 0 at that point. At this point final velocity would be 0, and here initial velocity is not given to us, so we'll consider initial velocity to be v naught. V naught is the initial velocity for this, the motion we have taken. Initial velocity is v naught, final velocity is 0 since the ball starts coming downward, and time taken is t by 2. So from the first equation of motion, that is v is equal to u plus at, this final velocity is 0. Clear? So u 0 is equal to u plus, since acceleration due to gravity is in negative direction, so it is g, and time is t by 2. So from here we get u is equal to g t by 2. So this is it isn't the initial velocity. What we have considered for this motion, the initial velocity is v naught. So this v naught we have got, that is equal to g into t by 2. So this is v naught, the initial velocity at this point, we know. So this we know. If we consider, listen me carefully, please listen me carefully. Now if we consider the motion from here to here, what I am saying, from here to here, go back into the time for just one, go back into the time, and if we consider this motion, when the ball started from this point, ended at that point, means when the man was about to catch the ball, the man had not catched the ball, misses the catch now. So from this to this point, if we consider the motion, we have the initial velocity u only, we have the initial velocity u, and for final velocity is this v naught for this motion, and height is h only, acceleration due to gravity would be g only. So we'll apply the third equation of motion since time is not given. So applying the third equation of motion, we will get if we apply the third equation of motion, we will get final velocity ka square, we will get v square is equal to u square plus 2as. This is the third equation of motion. So final velocity is v naught. V naught squared is, what is this v naught squared? It is g squared t squared by 4, isn't it? If you don't understand, let me write it as, what is, first of all tell me what is v. V is this v naught, final velocity. What is u? U is this initial velocity. What is a? A is g. A is g, and since g is in negative direction, sorry, eraser is not working. So yeah, if g is in negative direction, it will be negative. What is s? So s to g, we have s is h only. So this is the equation. Instead of v naught, we can apply this value. So this value would be equal to v naught is g t by 2 v g by 2 whole square, which will be equal to u square, which we have to find. So u square minus 2gh. Now by transposition we get u square is equal to g, this opening this g square t square by 4 plus we have this 2gh. Now if we will do this, so u, now if we remove this square from u, we will get the remaining portion in under root. So it will be g square t square by 4 plus 2gh. Now if I write it as, if I write it as into this second term, if I divide by 4 by 4, there is no change in the value. So we get u is equal to, if we take root 4 common, if we take, we are left with g square t square plus 4 into 2 8gh. We are left with 8gh under root, don't forget this, we have left with this under root. So our final answer is 1 by 4 will come out as 1 by 2 into root g square t square plus 8gh. This is the answer for this very complicated looking question. So thanks for watching. So this is the solution on your screen. You can take a screenshot. Thank you for watching the video. Thank you. Have a nice day.